In section 9.3 we are studying circles, and there are various parts to that. One is to find the length of a radius of a circle, given the length of a diameter, and vice versa. Given the diameter, find the radius. Then we find the circumference of a circle, given the length of a diameter or radius. And then find the area of a circle, given the length of a diameter or radius. And then we solve some applied problems involving circles. So here's an identifying figure, a circle. I'm sure you've seen all of that. And there are various parts to the circle, and it's important that you know which is which. So it has a center in the middle, O, and a line which goes across through the center is called a diameter, and then a segment from the center to the circumference is called a radius. So we have a radius, we have a diameter, and we have a center, and this, of course, is a circumference. Now, the relationship between diameter and radius is very simple. If the length d is the diameter of the circle and r is the length of the radius, then d equals 2 times r, or r is d divided by 2. Divide both sides of this equation by 2, the isolated r, and then r equals d divided by 2. Just from looking at it, it makes sense that the diameter is twice the radius, since the line AC goes through the center. So remember these formulas. So in exercise number 1, we are given the diameter, and we are to find the length of the radius. And since the radius is d divided by 2, is 20 divided by 2, which is equal to 10 meters. Since the diameter was given in terms of meters. In exercise 2, find the length of a diameter. Well, we know that the diameter is equal to 2 times the radius. And since the radius is 2.5 feet, it's 2 times 2.5, or 2 times 5 halves. And since the 2's cancel, d is equal to 5 feet. Now, the circumference of a circle is the distance around it. And calculating the circumference is similar to finding the perimeter of a polygon. In this case, the circumference and diameter of a circle is given by c equals pi times d, where the number pi is approximately 3.17, or about 22 divided by 7. It's an approximation. It's not an exact number. So here we are given a diameter of 18 inches, and we're supposed to find the circumference of the circle being given by this shape here. So here it is suggested to use 3.14 for pi. So c equals pi times d. In other words, 3.14 times 18 So following the guided solution, 3.14 times 18 inches. So that's then equal to 56.52 inches. So that is the circumference of this shape here. In exercise 4, we have a circle here, and we are supposed to find the circumference. So we know that the radius, r, is equal to 14 meters. And we're supposed to use 22 divided by 7 for pi. So following the formulas, c, the circumference, equals 2 times pi times r, we get c equals 2 times 22 divided by 7 times r, and r is equal to 14. So we can write that as 2 times 22 divided by 7 times 14 divided by 1. And since 7 goes into 14 two times, we have 2 times 22 times 2, where the last 2 comes from 7 divided by 14 being 2. And so this then is equal to 4 times 22, or 2 times 44, or 88 meters. Now the next exercise is about finding the perimeter of this figure, and use 3.14 for pi in this case. So how do we start? Well, we can think of this as the upper part being half a circle and the lower part being half a circle. So in other words, we have one circle with radius 3.2 yards, and then we have these two lengths here. Cover the half circle or semicircle's end. 7.1 yards here. So we've one complete circle with radius 3.2 yards. So let's sketch it in here. Again, it's consists of the upper part here and the lower part here. And the radius is 3.2 yards. So let's compute the circumference of the circle first, and then we add these two lengths to it. So C is equal to 2 times pi times r, 2 times 3.14, times the radius r being 3.2, so C is equal to the product of these three numbers. So this product is equal to 20.096 yard. And now we have the vertical lines, 7.1 yards long. And since there are two, we now have 7.1 plus 7.1 is equal to 14.2. So when we add the circumference, In other words, 2 of the half circles, giving us a full circle, plus the 2 vertical lengths, we have 2.096 plus 14.2, and that's equal to 34.296. Yards. Everything is in yards. Now, next is the area of a circle. And the area of a circle, where the radius is given, is equal to pi times r, or a equals pi times r squared. So here's the radius of the circle. The area is equal to pi times r squared. In number 6, we find the area of a circle, and we have to use 22 divided by 7 for pi. The radius is equal to 5 kilometers, and the formula for the area is pi times r. So in other words, it's 22 divided by 7 times 5 kilometers, which is 22 divided by 7 times 25 kilometers squared, and that's equal to 550 divided by 7 kilometers squared, and that is equal to 78 and 4/7 kilometers squared, or square kilometers. So number 7 is quite similar. Again, the area is equal to pi times r, and so we use 3.14 for pi, times 10.4 times 10.4, and when we form this product, we get 339.62 square centimeters. So always remember, when we're dealing with area, it is some unit squared. In the previous example, we had square kilometers. Let's revisit that. And here we have square centimeters, but area always has some measure, unit measure squared. Now we're looking at an applied problem. So the question is, which is larger and by how much? A 10-foot square flower bed or a 12-foot diameter round flower bed? So we have two problems here. So here's the square flower bed, 10 by 10 feet, and a circular one with a diameter of 12 feet. So we compute the area of the square flower bed, and of course the area is equal to, the length of the side squared, so 10 times 10 equals 100 square feet. So that's the area of the square. I'm going to make a little s here for the square. Now the area of the circular one is equal to 2 pi r squared, so pi times r squared. Now in this case we're not given r, but we're given the diameter. But we know that r is equal to d divided by 2. In other words, it's equal to 12 divided by 2, or the radius is equal to 6 feet. So, so 3.14 times r, 6 times 6, so when we look at the two areas, for the square one and the round one, 100 square feet, of course, is less than 113.04, so the round flower bed is larger. To determine the second question, by how much, we subtract the smaller area from the large area, and in other words 113.04 minus 100 is equal to 13.04 square feet. In other words, by 13.04 square feet. So here we have the results summarized, that the round flower bed is larger, and is larger by 13.04 square feet. And this is the end of section 9.3.